Welcome to our channel. Let's look at today's daily challenge problem. Maximum difference between even and odd frequency. This is the first of such problem. So in this problem, in this video, we can solve it just using a for loop or with the help of a dictionary. And also, if you want, you can also solve it using heap data structure. Let's see how can we do this problem. So here we are given a string and consisting of lowercase English letters. So we want to find the maximum difference in frequency. So the frequency we want this one to be maximized. So where A1 frequency is odd and A2 frequency is even. And also the problem assumes that S contains at least one character with an odd frequency and one with an even frequency. This greatly simplifies the problem. So here first, we can get count the frequency, the character and their frequency. So we can use collections counter, right? So S. So you can print out that, right? So this gives you, for example, A appears 5 times, and B appears 2 times, and C appears 1 time. So the largest odd frequency is 5, and the smallest even frequency is 2. So 5 minus 2 is 3. So this is the example 1 actually, right? So let me comment out this one. And then let's initialize 2 variables. One is odd, one is even. Because for odd, I want to find the maximum one. So I can first initialize a 0. For even one, I want to find the smallest one. So at the very beginning, I can make a large number. So here you can use float infinity, or so the length of the S is at most 100. So you can also use, say, 101, right? For even, you can use 101. Just as large enough, that will be great, will be sufficient. Then we are going to iterate, right? So we only care about the frequency. For frequency, you count values, right? So if frequency modulo 2 equals 1, this means it's odd, right? For odd, I want to find maximum, right? To maximize this term. So what I want to do is odd equals max odd and the current frequency. Otherwise, the frequency would be even. So for even, I want to find the minimum. So it's even and the frequency. And then later, I just need to return odd minus even. So let's run it. Yeah, it passes the 2 cases. So now let's look at the generic case. Let's run it again. It's actually, so this is linear, all right? This is also linear, so it's linear time complexity. So this one, all right? So actually I want to write a more slightly complex one. So I can use heap. This is just for, for practice, right? So notice that for odd, I want to find the maximum one. So I can use a negative frequency to put the smallest in the top, then I just put a negative sign. And for even, I just use the positive one. So here you can first have this line, right? So it can have odd heap and even heap. So first I want to comment that this slightly complicates the coding. But I just want to show you this possibility or as a practice of heap. So now for frequency in count values, right? So if frequency modulo 2 equals 1, it means it's odd. So odd, I'm going to do heap push. Push this to the heap. Push to the heap this frequency, negative frequency, right? Otherwise, it's even. So just heap q, heap push, push to I guess even heap frequency, and this is odd heap, right? So here actually we can print out the odd heap and the even heap. Yeah, for the first example, 5 corresponding to the frequency of A, and so here this 2 corresponds to this B. So what we want to return actually is return heap Q, not heap Q, odd heap at the root, and then I put a -1. So this will be the largest odd frequency. So minus the smallest even frequency. So this is the heap 0, right? So let's run it. Yeah, it passes the 2 cases. Let me comment out this one, and then I'm going to submit. Yeah, this also works, but actually this time complexity is better, right? But it's this 100%. Yeah, this is the second one. So with that said, I guess that's it for the current practice. Thank you for watching.